We represent compounds using chemical formulas. Chemical formulas tell us which elements are present in the compound and the relative numbers of each number of atoms or ions of each element. So we use subscripts and element symbols to write chemical formulas. So we have a subscript following the element symbol, and that tells us how many atoms of that element are in the compound. So water is H2O. H2 tells me there are 2 hydrogen atoms and 1 oxygen atom. We don't write the 1 because if it was something other than 1, we'd write that number. And if it was 0, we wouldn't write the O. So if you just see the element symbol, that means there's 1 of them. Sodium chloride, NaCl, it's 1 sodium, 1 chlorine. Carbon tetrachloride, CCl4. Now this one can be a little confusing, right? Because this L can look like a capital I or a 1 and mix this up a little. But then we would have to wonder, well, why did they put Cc instead of C2? So this is 2 elements, carbon and chlorine, 1 carbon and 4 chlorines. There are different types of chemical formulas. An empirical formula just gives us the relative number of atoms. So, for example, hydrogen peroxide, its molecular formula is H2O. That's its kind of regular formula. But the empirical formula is just the ratio. So if we think of this 2 to 2 as a ratio, that could be simplified to 1 to 1, right? So HO would be the empirical formula. And empirical just means derived from experiment. So the most basic types of experiments that can give you chemical formulas do not tell you how many atoms are in a specific molecule, but they'll tell you the ratio of the elements. So the molecular formula, this is the kind of normal formula. This tells us how many actual atoms are in each. So for something like C4H8, 1 molecule has 4 carbons and 8 hydrogens. We can simplify that to write the empirical formula, which is CH2. CH2 is not as useful to us, but that would be the empirical formula. B2H6, the 2 and the 6 have a common factor. We can divide them both by 2, and the simplest ratio is BH3. In carbon tetrachloride, there's 1 carbon and 4 chlorines. The only common factor is 1. And so the empirical formula and the molecular formula are one and the same. And that can certainly happen. Structural formulas use lines to show us how the atoms are connected. In the molecular formula, it doesn't say anything about how they're connected. So we use lines in the structural formulas, and we use a single line for single bonds, a double line for double bonds, and a triple line for triple bonds. So which kind of formula that we're going to use depends on how much we know about the compound and also how much we want to tell the reader. Structural formula gives you the most information. It's really hard to type, though. A lot of things you have to use some sort of a drawing program. An empirical formula communicates the least amount of information. So the molecular formula is kind of in between, and that's what we usually use. So let's find the empirical formulas for these compounds. These are molecular formulas. What would the empirical formula be for C5H12? It's C5H12. Because if you think of that as a ratio, 5 to 12, or as a fraction, 5/12, right? Can't be simplified. How about HG2Cl2? HgCl. this was a 2-to-2 ratio. Here, the ratio is the same. 1-to-1 is just a simplified version of that ratio. Here we've got 3 elements. Can that be simplified? Yeah, 2, 4, and 2 are all divisible by 2. So if we divide each subscript by 2, we get CH2O. If you write a 1 there, I won't mark it wrong, but we don't do that. Any questions? Molecular models are another way we can indicate or specify a compound. Ball and stick models are useful. These are examples of ball and stick models. They're so-called because they use balls and sticks, right? Such clever names we have. We actually have a color coding system for those atoms. This is not anything you need to memorize, but typically hydrogen is white, carbon's black, and you see all these other guys. So if I look at, let's pick one that I know. If I look at this guy, the 2 black balls represent 2 carbon atoms. The 2 white balls represent 2 hydrogen atoms, and the 2 green balls represent 2 chlorine atoms. So I could write a molecular formula for this, which would be C2H2Cl2.
How do you know what letter to write first?
How do I know what?
What letter to write first?
Oh, that's an excellent question. There's a rule for that, but you're going to do fine in the class without knowing it.
Okay.
It's the one that's more metallic comes first. Yeah. That's a good question, though. So here's the molecular formula that we've talked about. This is an example of a structural formula. We see the letters representing the atoms and lines representing how they're connected. This is the ball and stick model. And this was what is called a space filling model. This is more like what a molecule would actually look like if we could see it. So this table just shows several different compounds and the different types of formulas for them. Let's just look at glucose, which is a sugar. Its empirical formula is quite simple. Its molecular formula is a little more complicated. And then we see the structural formula and the ball and stick model and the space filling model. And these are going to give us more information. There are actually a lot of compounds with the same molecular formula. Sucrose is one of them. Has the same chemical formula, but it's not the same because it's arranged a little bit differently. So these are nice. This we don't use as much because, especially if it's not a physical 3D object that you're handling, you can't see what's on the other side, right? You can't see through it. And so that's why the ball and stick model is used more frequently, is because you can look behind things and see everything else.